In JetBrains' recent developer survey, it was not a surprise to see that Apache Maven is the most popular build system used by Java developers. Every 3 or 4 Java developers prefer to use Maven as their build system. And why is that? Because Maven is a powerful tool with a lot of features. However, as developers, you might have witnessed certain patterns. I mean, certain Maven features that new and experienced developers struggle with, especially within a team, such as managing complex configuration with POM files, understanding the finer details of Maven's lifecycle, managing dependency. I think that's the most difficult one, and many others. Do I know answers to all these questions? Do I know how to address all these pain points? No, I don't. But our speaker, Chandra Guntur, definitely does. Hi, everyone. Thanks for joining in for another IntelliJ IDEA live stream. I'm your host, Mala Gupta, and now let me add our speaker to the stream. Hey, Chandra, pleasure to have you present with us today.
Hello. Hello, everybody.
So, Chandra is a popular leader in the Java community and doesn't really need any introduction. But as a host, let me quickly introduce Chandra. He's a distinguished engineer at BNY Mellon, JCPEC representative, fellow Java champion, leads 2 Java user groups. Wow, that is great. Also a conference speaker and a lot of others, but I'm just including the main and the big ones. So Chandra, before I let you take the stage and start with your session, I have a quick question for you. So, how often, because as I know, when we were talking about this session, you mentioned that a lot of developers, whether they are new developers or experienced developers, they seem to have some issues when working with Maven in a team. So, how often do you see them struggle with with the Maven issues, and are there any issues that kind of comes to you again and again? People ask the same questions again and again.
That's a great question, and thank you for that. Thank you, JetBrains, for hosting me, and thank you to everyone who's attending. So the common problem points that I find are that folk who use Maven seem to just know the commands that exist and start using them. And if there's any more complexity to those commands, it sort of throws them off because everyone's IDE or terminal is differently set up with different settings, and sometimes collaboration
Mhm.
becomes more difficult with that. In addition, with recent trends in Java, with the release cadence having moved so quickly, upgrading Java versions also becomes a hassle. And there are a lot of challenges when you have a Maven project and you want to upgrade to Java. And there are simple ways to do this, and that's something we will explain today. In addition, a lot of
Mhm.
folk have questions and concerns about the internal workings of Maven, especially with regards to dependency resolution. So I guess hopefully we'll try to cover all these topics today. Time permitting, we'll also go through some demos with the same.
Thank you so much. And that will, I think, you kind of give us a gist of the main problems that developers see. And I know that when we were also talking about the session, I know you are covering a lot more than that. So I will not take a lot of your time. And before I let you take the center stage, let me share some housekeeping details quick, fast. Everyone who's watching, please use the YouTube chat to post your questions. We'll try to answer your question as soon as you post them. Chandra will also take breaks during his session to answer your questions. And of course, he'll answer the remaining question towards the end of the session. One of the most commonly asked question is the session being recorded? Yes, it will be. And it will be hosted on IntelliJ IDEA's YouTube channel and also on JetBrains' Twitch channel. So if you haven't already subscribed to this channel, now is the time to do so so that you don't miss similar content in the future. And if you like today's session, which I'm sure you will, do not forget to like the video. So Chandra, I'll let you get on with your session and have fun.
Great. Thank you so much. So, just a gentle introduction. I do not like using a lot of presentation material, but we will start this session with some amount of presentation, and then we will move into the IDE where we can see exactly what we're talking about in the presentation. The presentation is somewhat useful to get the basics down and to sort of refresh basics for those of you who already know these details about Apache Maven. So, without further ado, I'm going to start sharing my screen now.
So Chandra, a quick point. We need you to switch to your slides. Yes, it's done now.
Yes.
I'm going backstage again. Sorry for the interruption.
No problem. All right. So today's topic, I'll cover a short amount of slides in this. I'm not going to spend a lot of time on the slides, but I do want to cover this. So we'll talk about Apache Maven and look at some of the finer details of how Apache Maven works. I'm going to breeze through some slides. These slides are available on SlideShare should you want to later on go back and peruse them. But the intent is not to bore you to details with every single slide and reading through those. So I'll keep it short. I'll keep it quick. My apologies if it moves too quickly. I'll focus on some sections where we need to spend more time. So what is Apache Maven? It's a very powerful build management tool. And while it's primarily used for building Java projects, you can build for other languages as well. And one of the key features of Apache Maven is that it follows convention over configuration models. And we'll take a look at that briefly. Um, so what is build management? Build management is more than just a build tool. Build management gives you the capabilities of compiling, creating packaged executables, being able to test your code internally, generate documentation, reports, even test metrics, and deploy to some sort of a server or repository. And we'll cover all of those. What is convention over configuration? This is one slide where I'll spend more time. Convention over configuration is a software design paradigm, and it greatly reduces the number of decisions a developer has to make. And how does this do this? It basically makes a few amount of opinionated assumptions, and the developer is allowed to override those assumptions as they go along, setting up their project. The sensible default assumptions are all available, and we'll take a look at how the hierarchy is established for those. An example of the convention over configuration is on the right-hand side, where you see a small picture of a directory structure. Typical Apache Maven directories look like so, where there's a project, and under the project, there is a source that you expect to find. So there is no astonishment. It follows the principle of least astonishment. So you have a source, and under the source, you typically have a main. And if you have a Java project, under the main, you have a Java directory. In addition, parallel to the Java directory, you have resources that the Java code may actually rely or use. Similarly, parallel to the main, you have a test, and under the test, you have a Java and resources, which are parallel to the main's Java and resources, where the Java code in the test directory gets to test whatever is written in the main branch or the main directory. The instruction set for Apache Maven is produced through a POM, and we'll take a look at the POM. You can see at the bottom of the picture, there is a pom.xml file at the root of the project. So these are some terminology we'll use. The pom.xml, the root of the project, etc., are terms that we'll frequently be using over the course of this, next 1 hour. So what is a POM? And a lot of times, this was initially, I would ask this question, what is a POM? Because I did not understand. And I come from the Maven 1 world where it was called a project.xml, and it has been replaced with a POM. So what is a POM? Is it a Pomeranian? Is it pomegranate juice? Is it one of the pom-poms? What is it? And the right answer to that is it is none of the above. POM is a project object model. And a POM lists what dependencies you use in your project, what plugins you set up, what properties you have for your project, any kind of inheritance details that you have, and profiles. And we'll take a look at some of these in detail as we go along. But just to let you know, a POM is essentially a project object model. And just an excerpt of one of the POMs I found in one of my source code bases. We don't have to delve through this, but it's an XML construct for most part. That being said, a POM is not limited to XML. You can write your POM in YAML. You can write it in JSON. It's a polyglot-driven structure. Maven supports multiple languages for declaring a POM. The typical standard structure is in XML, and most people have come to rely on a pom.xml file at the root of their projects. What are the benefits? I don't want to spend too much time. I mean, most of you are here because you probably know that Apache Maven is beneficial, or you're forced to use it. My apologies if you are. The benefits of using Apache Maven are, it's visibility. You have visibility into the build logs. You have reusability, verifiability. I won't read the whole list, but there is a lot of features that Apache Maven produces for you, which you can benefit from. As we've already talked about the build management tool, Apache Maven checks almost every single box of a build management tool for you. So once again, I will not read through the slide. The slides are available, and I'll share a link to the slide share right after the session in the chat. And how does Apache Maven work is one section where I want to spend some time going over, because this sort of is a basic a lot of people sort of skip or miss. So if you already know this, consider this a refresher. So let's assume a simple project, and you can ignore that red box on the top right. It is more meant for sessions where I'm doing a deep dive into Apache Maven. Since we're talking through it here, you can ignore that red box. But if you don't follow along with what I'm verbally saying, the same content is actually going to show up in that red box. So let's assume you have a project, with the standard known directory structure that we already saw an image of, and you have your source code in there. In addition to the source code, you basically create what is called a project object model, a pom.xml, if I may. And like we already discussed earlier, a POM contains your dependencies, plugins, profiles, etc. And that together is a pom.xml file. The next step we do is we actually download the Apache Maven executable and run the Maven command against the POM. So we point it to the root directory, the root of the project, and there's a POM XML file, and we point it to that, and we run an Apache Maven command on it. When we run this command, a few things happen. The first thing that happens is Maven goes through your POM XML file or similar and assembles what is known as an effective POM. And we'll cover effective POM in a bit, but just letting you know, it first creates an effective POM, right? It has various settings, it uses some defaults, and then your POM gets to override some of those settings and defaults. And that is together what is known as an effective POM. It then basically goes and checks if you have a local repository cache. So a local repository cache is something that exists on your local machine or host where you're running the Maven command. So there is typically an internet Maven repository, which hosts a lot of these things that you would need to build your project or run your project. In addition to that, you may have a local copy of it, so you reduce your network I/O. And Maven looks for that local repository. Should it find one, it can use that. Should it not find one, it goes to the internet Maven repository. This should be transparent to you, but it may come in handy for you to know this in a bit. So the next thing Maven does is, since you run a command with Maven, it goes through either your local repository cache or your internet Maven repository and pulls all dependencies and plugins. These are essentially other jar files, war files, or similarly packaged executables that your project either depends on for compilation or runtime. All that is pulled in into your project. And once it's pulled in, if it was not available in your local repository, it gets saved into your local repository for the next build purposes. So you reduce your network I/O using this local repository cache. In addition, Maven uses profiles. So profiles are basically mechanisms that allow for alternate execution paths. They allow for different configurations or different environment-based builds, etc. Is all configured using profiles. So consider profiles as alternate ways to build your code. Instead of you creating multiple POM XML files, one for dev, one for QA, one for prod, you can just have different profiles within the same POM XML file. That is the base purpose of a profile. There's a lot more profiles can do, but I'm just giving you a 50,000 foot overview of what a profile can do. In addition, Maven has lifecycle build phases, and these lifecycle build phases get executed by Maven based upon the command you run. And we'll take a look at the command in a bit. So that is, in a sense, what Maven execution is doing, picking up the profile, determining the profiles to load, and running the lifecycle and build phases on those particular profiles. Optionally, Maven can also then deposit your built artifact. Artifact is the output of your build or whatever Maven command you run. That artifact, said artifact, can be pushed either into your local repository when you run, let us say, mvn install command. It would actually push content to your local repository, or you could have some sort of a distribution management section set up, which we'll talk about in a bit, which allows you to push the same artifact out to the internet for others to use. So these are optional. Most of the time, you may not even need to do an install command. Maybe a lesser command than that would work for you because you're just testing your code on your local machine. But this facility exists and it's optional. So overall, as a summary, these are the steps that you take in order to run Apache Maven. I mean, I've skipped a lot of nitty-gritty details, but overall, this is something easy to understand is that, hey, you create a POM XML file, you run a Maven command against it, Maven assembles an effective POM, Maven pulls dependencies and plugins from somewhere and executes some commands and may optionally push content back out elsewhere. And that is how Apache Maven generally works. So what is an effective POM? We talked about an effective POM in the previous slide. We took a look at there being an assemblage of an effective POM. So what is an effective POM? It's an assembly of execution steps. What do you run? It's got properties that you use for your particular build, and it has profile information. It has all the content that Maven can execute for your project. It has an exhaustive set of dependencies and plugins that are needed to build your project. And we'll cover these. Don't be, if you're not familiar with these terms, we will make you familiar in the next few minutes. It lists all dependencies and their transitive dependencies. We'll cover this too. Any dependency conflict resolution is also handled at this stage, and it is ready for execution by a Maven executable. So effective POM is essentially a graph of everything Maven needs in order to run your executable commands. How does it work? So Maven is written in Java, and it has internal defaults in the Java code, in its own Java code that you should not change. There are tiny icons right next to, in the center of the screen, which tell you what you should change, what you shouldn't change. So please do pay attention to those. So Maven internal defaults are in the Java code of Maven. They're compiled. So ideally, you will not be changing them unless you are one of the contributors to Maven itself. Maven also has what is called a default POM. It's also known as a super POM or a base POM, and it exists in the Maven jar file. So ideally, you should not change this. And it contains everything that you need should you not provide a value for it. So the defaults, the sensible defaults, the convention over configuration exists in the super POM, base POM, default POM, whatever you call it. In addition to those, there are some settings that you can change. So let's take a look at some of these. The third row that you see is a settings file that is located under the Maven installation itself. So when you install Apache Maven, under its own conf directory, there is a settings.xml file. Avoid changing that. Your corporate structure may actually prescribe a change. You, as an individual user, should avoid changing the global settings on Maven. In addition to that, Maven allows you to customize your own settings. Let us assume you have specific settings on which repository you want to, which repository you have affinity to, and which you want to avoid. What your password is when you go to some authenticated repository, etc., is all stored inside a settings XML file that's located under your user home. So it's very private to you. However, what you put in your settings XML file impacts all Maven projects in your local machine. So be aware of that. Any change here impacts every project that uses Maven on your specific host or machine. So be careful when you change this, but it is changeable. So typically with the checkered flag that I have there, it indicates that make a change once at the start, similar to a racetrack or whatever. Make a change at the start and avoid changing it afterwards. What you can and should work on is either your parent or BOM specified in a POM file. If you don't know these terms, we will cover them in the next few slides. Those are things you can change. The project POM itself, you can change. A combination of all of these, where every lower layer overrides whatever was in the previous layer, is called an effective POM. And the effective POM is what Maven creates for you, and it is read only. So you cannot change it, right? So that is something you should be aware of. And once we switch over to the IDE, we will take a look at an effective POM that gets generated. So bear with me as I go through the deck. We'll also take a look at the same thing in the IDE later on. So any questions so far, Mala? I think I've been going a bit faster because I want to get rid of the presentation material quickly.
Hi, Chandra. Yes, there are a couple of questions, but most of them are related to IntelliJ IDEA, very specific to the IDE. So Nikita is
Okay.
on the stream and he's answering the questions because they are
Oh, perfect.
really, yeah.
Hi, Nikita.
Thank you. Thank you so much.
Awesome, thank you. All right, so we did cover a few terms here which were kind of strange. We mentioned parent, we mentioned bomb on the third to last line. And these are terms that we've not introduced in the past. There is a bill of materials POM. What is that? So let us first quickly delve into some POM hierarchies and take a look at what these mean. So there are three hierarchies in Maven that I would like to talk about. There are multiple, but I'm going to cover only the three because these are very, I guess, commonly found and used. To your left, where it says parentage, at least to my left, you see parentage. And a parent POM is essentially where you have a pom.xml file, either within your own directory structures or elsewhere located on the internet or in a local repository cache, and it contains some content. And then you have another parent POM, which is, this is an example, it's hypothetical. So you may not have two, you may have five, you may have one, right? I just provided an example of three layers here. You can have any number of layers of parent POMs. But you have a parent POM, and this parent POM declares a few dependencies, plugins, and repositories. And let us assume you have your own project. You can actually declare a parent POM as a parent, and therefore inherit all the dependencies, plugins, and properties available in the parent POM to your own POM. The parentage in Apache Maven is kind of interesting, is that the project knows its parent, but the parent does not know the project. So the parent POM has no idea that the child POM exists, but the child POM knows about its parent. So parentage is one way, and the child POM has to declare parentage to the parent. The second model will actually tell us the opposite way, which is the center column that you see, where you have an aggregation or a reactor POM. An aggregator POM is where you have one POM that is located elsewhere, and it is invoking a list of POMs or module POMs, right? So module 1 POM, module 2 POM, 3, and 4 are being called in that order by the aggregator POM. Now, the aggregator POM itself has complete knowledge of the modules, but the modules may not have a knowledge about the aggregator. The module POM may run independently, it may not even depend on anything else, but an aggregator forces, I guess, the sequence in which these particular modules will get built. So a module does not know its parent, but the parent knows the module. So that is the difference between parentage and aggregation. Can you combine these two? Absolutely, yes. It is possible for you to create an aggregator POM in the parent POM, and it's possible for you to set a parent in the module to the aggregator itself. So both are possible. So the combinations are either parentage or aggregation or a combination of both. Everything is possible, and we'll see an example of some excerpts of code in the next slide. What is more interesting and recent is a bill of materials POM located on the right-hand column. Now, the bill of materials POM is similar to aggregate in that it has some amount of content, and your project POMs somehow inherit some values from it. There is no parentage. What the project POMs declare is, hey, I'm going to import this bill of material POM. I have no inheritance reason for this, and I just need certain values from there. The values I need are dependencies, plugins, properties, etc. But I don't need to necessarily inherit from this, and I need to inherit from more than one bill of materials POM. So it's like an interface in Java where I can specify multiple interfaces, and I get all of their behavior, I guess, contracts, but I get none of the inheritance from that. So it's a similar concept with the bill of materials. The bill of materials POM is similar to aggregate POM in that it does not know the projects that use it. And the projects know about the bill of material POM because they import the bill of materials. Once again, similar to aggregation, you can set the project POM to have some parentage, or you can do the aggregation, right? So it is possible for you to do that. It is generally not recommended or not seen in the wild. So use caution if you are aggregating, for instance, in a bill of material POM. It sort of defeats the purpose of bill of materials. So I know this was a complex topic. So Mala, one more time, are there any questions about this before I show the examples of this?
Yes, sorry, I forgot to unmute myself. Again, questions which are specific to IDEA, and Nikita is answering them, so I can let you move forward with your session.
Perfect, thank you. So here are the examples, and pardon the fonts; they're small. I tried to fit as much as I could within one screen. The parentage, as you see on the left side, is basically where I declare a parent in my POM XML file, and I specify a group ID, an artifact ID, and a version. We'll cover more about this in a bit, but I just wanted to let you know that uh, in my POM, known as a datetime fetcher POM, I have a parent of something else, and therefore I'm establishing parentage, right? Um, in this case, let's take a look at this center column, and you'll notice that I am looking at the parent POM for that particular parent, and it declares three modules, which is an aggregation mechanism. So when I run this POM with some Maven command, the command will be run on datetime fetcher first, then on the greeting module, and then on the greeting generator module. So that is the sequence in which modules will be executed. And the content that has the build plugin management section you see below is all inherited by the POM on the left because it declares it as a parent. So I've sort of combined a parentage and aggregation in this example. And the third, several of you may be familiar with Spring Boot, and Spring Boot does have a bill of materials, which basically lists all dependencies that work very well with that given version of Spring Boot. And here we are importing a Spring Framework BOM, a bill of materials, and you'll notice that there is a scope. One of the fields is scope, and it says import. So I'm actually importing, I'm not inheriting, I'm importing all dependencies, plugins, and properties from a certain BOM that exists elsewhere on the internet. It has nothing to do with either what I built or something that was built in collaboration with me. It exists on the internet, and I'm able to import certain content from it. Avoid aggregation in bill of materials, as we talked about before, but this is a POM hierarchy example. Awesome. Next, we'll shift to some deeper topics that are actually relevant to our conversation today, and we'll actually be able to see live examples in the IDE right after that. Maven works on the principle of life cycles. There are three standard life cycles as of Maven 3.x. Maven 4 does introduce a fourth one. We'll not cover that today, but there are three of them today. There is a clean life cycle, there is a build or a default life cycle, and then there is a site life cycle. Um, Life cycles are basically just ways in which Maven can execute commands, and these life cycles have phases, similar to how a human has a life cycle, and within we have phases in our life cycle. Like when you grow up, when you're born, you're going through a teething stage, then you have your terrible twos, etc. Those are phases in your life. Similarly, Maven has life cycles, and these life cycles have phases in them. So the phases for clean are pre-clean, clean, and post-clean, and they're executed in that order. So sequence is maintained. And similarly, you have standard life cycles for build. There are 23 of them. I will not read them out to you, but they're all available. And then the site life cycle is the third life cycle that's available, and it has four phases in it. The next more interesting slide is each of these life cycles have something called a default phase associated with them. And it'll come in handy when we look at the IDE. So on this slide, you notice that under the clean and the site phase life cycles, you have clean and site as the default phases. So when you call an mbn clean command, what you're actually calling is the clean phase of the clean life cycle, right? So be aware of that. You're not just calling a life cycle, you're calling a specific phase in that life cycle because that is the default phase. Should you want to call a post clean, you will actually say mbn clean colon post dash clean. And that is how you would invoke that specific phase. So be aware of that. And then most of you, if you look at your IDE, which we will in a few minutes from now, will notice that not all of these life cycle phases show up in your IDE. And there is a good reason for that, right? So in your IDE, if you open up let's say the Maven tool window, I'm going to speak specific to IntelliJ, that's what I use. But if should you use any other IDE, you may not find all of the phases listed in the Maven tool window or whatever it is called in your IDE. And that is because they're not normal to directly be invoked. So you will not see a pre-clean, you'll not see a post-clean, you'll see a clean, you'll see a validate, a compile, test, package, verify, etc. And these are good junctions in the phases which provide a clean outcome. So let's assume if we were to stop at process resources on the build lifecycle, it leaves your build in a hanging state. It has not cleaned up after itself. It has not done anything. Similarly, if you were to call a post-integration test, the post-integration test does not actually produce the result of the integration test. So calling that is not very useful. I mean, why would you do that? So there are some standard build phases that you will invoke, and that's what your IDE show. Can I go ahead and also invoke other commands because I want to? Yes. These are not standard, so they're not visible normally. Okay, so be aware of that. The last thing what I'm going to do is actually show you how a Maven clean compile works. So here is your Maven clean compile. When you call this command from a command prompt or from your IDE, what is happening is first the clean lifecycle is picked up. And since it has to call the default phase clean, it calls pre-clean and then the clean is called. Likewise, when you call the compile phase, it knows you're referring to the default lifecycle and it looks for compile and finds every phase ahead of it and invokes those phases for you. So what gets called is a pre-clean, clean, validate, initialize, generate, process, and compile. That's how Maven works. Just a word summary of exactly what I said is available, so I will not read this out to you. But a life cycle itself and a phase itself don't do anything, right? They're just phases. And a phase in your life is meaningless. It is because something is happening in your life, it is declared as a phase in your life. Similarly, with Maven, um, life cycle phases, when invoked, do nothing by themselves. What works under the hood is there is a plugin or a set of plugins, and these plugins are known as mojos, and they have goals. Goals are essentially what get executed when the phases are invoked. So a goal is associated with a phase, and this phase, when you get to that phase, all plugin goals that match this phase can get executed. In this example, you notice that plugin 1 name 2 associates with phase 1. Similarly, plugin 3 phase 1 executes with phase 1. Name 5 executes with phase 1. So when you call phase 1 of that lifecycle, um, Maven can pick up plugin 1 goal name 2 and plugin 3 goal name 5 for you. Similarly, you can also invoke plugins directly in case you notice a plugin 2 name 4 is not tied to any phase. You can actually directly call the plugin and the goal name, and it'll execute for you. You don't need to wait for a life cycle, so you can skip life cycles and actually call direct plugin goals. A good example of this is if you've ever done any debugging on Maven, you may want to call the Maven clean, and then after that, you can say dependency colon tree. It is not tied to any phase, but you call the dependency tree to look at what dependencies your POM XML file has. And that's possible to do. And we'll take a look at that in a demo in a few seconds from now. Whatever I just verbalized is also written in text here for you to consume later. And the last part I want to talk before we switch to the IDE is about dependencies. The way Maven works is Maven has dependencies that you are allowed to put in your POM, and these dependencies may have sub-dependencies. So they may actually need other libraries for them to work, either to compile or to run. In this example, I've invoked, let us say, dependency 1, and I put it on my POM XML file. This dependency has a further graph of all dependencies it depends on. And let's assume I don't want number 4. So Maven provides me an exclusion mechanism by means of which I can exclude the number 4 and say, I don't want this dependency. Therefore, that dependency and any of its transitive dependencies are ignored and not put into my dependency graph. So let's assume I have number 2 and 3 are the dependent sub-dependencies or transitives that I pull in. These have further transitives. And among those, if you look at number 5, it shows up as an optional dependency. An optional dependency is something that is possible to exist. If you have it on your class path, it'll be used. If you don't have it, it is going to be ignored. A good example of an optional dependency is, let's assume you create a JDBC based outcome, and you are allowed to use any database you want. So you can optionally declare, let us say, Oracle database, Mongo database, whatever databases you have as optional jar files, but you don't need all of them. So why build all of those transitive dependencies and bring them over? If you were to put one of those jar files in your class path elsewhere, it'll get picked up and used. If you don't, it's going to be ignored. That's an example of using an optional dependency. The last slide I wanted to share is how does Maven do dependency resolution? And this is I guess, a point of conflict for a lot of people. It's a bone of contention. So let's quickly go through some of the very simple ways in which Maven works. You have dependencies D1, D2, D3, and D4 to your left. They have transitive dependencies, and we are focused on dependency DX in blue everywhere. Notice the version numbers, they're also in red on to your right. So I have dependency version 1.0, 1.2, 1.3, and 1.5. The way Maven works is it looks for the nearest dependency and closest to the resolution path. So let us see how this works. In this case, I have a dependency DX that is version 1.0, 1.2, 1.3, and 1.5. So logic would dictate, hey, 1.5 is the biggest number. Why would Maven not pick this up, right? So let's see why that is not the case. So the way Maven works is it goes through the nearest depth in depth. This is not nearest. This is at the second level depth. This is at the first level depth. This is at the fourth level depth, and D4 has it at the second level depth. So the nearest in depth is either version 1.2 or 1.5. Which one is the first in the resolution path? Here, I notice that D2's dependency DX is first, so it will get picked up, not version 1.5. And for those of you who are wondering, why does Maven not just do a digital compare? It is because version numbers are not just digits. There is no rule. You can actually create version numbers with strings in them. So a comparison is near impossible, which is why Maven goes with the concept of nearest in depth and first in resolution path. Hopefully that makes it clear. And before I switch to the IDEs, if anyone has any questions, I'd like to take those now.
Um, hey, Chandra. So we have a couple of appreciation posts for you. That a very good explanation and a very good theory class. So thank you so much for that. So there's one question which is not related to IDE, which is by Sagar. And I know you mentioned about you had examples when you covered the aggregation and POM. And so he is asking, could you share an example when one makes sense and the other doesn't? He's talking about the bill of materials.
I'm assuming the question is, when do I use bill of materials over aggregation?
Yes, when would one
Okay.
make sense over the other?
Great. So an aggregation is
Mm.
something where you have control over your, I guess, child projects that you want to run in a sequence, right? An aggregation is more of a command concept. It's just like, hey, I want to run module one, then I want to run module two, and so on in that order. Or these are the modules that need to work together. I need module one built before I can execute module two, so force it. So rather than the excerpt, let me go here. This is a strong hierarchy where there is a controlling element in the aggregator form. A bill of material form is a loose hierarchy. There is no hierarchy, in fact. All the bill of material says is, I have some content. If you want to use it, refer to me. But I don't need to know who you are. So that's when you use a bill of materials. A bill of materials is more like, I have declared some things that you can use. Feel free to use these. But don't tell me who you are. I don't need to know. So it is almost exactly the opposite of what an aggregator does, which controls the sequence. A bill of material has zero control and zero knowledge, in fact, of what your forms are, right? So both a parent form and a bill of material form can choose to ignore who's using them, right? An aggregator form
Mm.
cannot. An aggregator form actually controls that. So that's the big difference. I don't know if that makes it clear.
I think it does. And if it doesn't, if he has any follow up question, then we'll take it later then.
Okay, great. Awesome.
Thank
So
you.
before I exit the IDE, am sorry, before I exit to the IDE, I just wanted to let you know, this is not the end of the, I guess, deck. There is more content in this deck. And what I do is, in my appendix, I have a complete reference to the Maven Form project, including, I guess, navigable sections to dependency management, build, and profiles. So here's the build, and then there's the dependency management, plugin management, and profiles. So these are available in case you wanted to sort of go through what the POM XML file has as an exhaustive list, and it's all listed out here. In addition, how do you configure Apache Maven is also listed. There are a few things, and I have a blog which is listed down below, which covers all of these details. And in addition, a lot of people have confusion about what a snapshot versus a release build is. So I have a sort of an explanation of that on the slide deck as well. So be aware. I will share a link of this presentation for anyone who's interested in that. Awesome. So with that, I'm just going to move to the IDE because that's where I want to focus most of our time. So this is my IntelliJ. I have set up a small project, and it's a very simple project to set up. So I don't want to bore you to details about how I set it up. So it's a simple Java project. I just created it last night, in fact. And under the source, I have a main and I have an app. It's a very rigorous app. It has a main method that prints hello world, right? And then I have a test a directory which does an app test, and it tests some code. This is all auto-generated from IntelliJ, by the way. So I didn't do much with this. The only thing I did was to actually intentionally mess up my POM XML file. And I wanted to share with you some of the pain points this POM XML file has for either a new developer or someone who's working in a large team, and how do we go about fixing these. So let's take a quick look at some of the things we can do with our IDE, right? So let me first get rid of the HTTPS to show you what happens. So IntelliJ is very smart. It figures out that I have a problem here. And it tells me that my HTTP links are not secure. And it actually prompts me to change the prefix to an HTTPS. So I can make that change and one of my problems disappears. So if I were to have HTTP, you'll notice that there is a weak warning. And the weak warning is basically that I'm using HTTP URLs. So IntelliJ knows that, and it sort of constantly monitors whatever content exists in my entity. Now you'll notice that the HTTP occurs elsewhere, but these are not controlled. These are accepted changes. So there are some suppressions possible. So for instance, I could actually go here, and if I were to option enter or alt enter, you can ignore certain URLs as well. So IntelliJ has the intelligence to either suggest a change for you or ignore the URL. So both are possible. In my case, I would prefer to follow IntelliJ's intention. The next thing you notice is my code is still on Java 8 and I want to upgrade, right? What is the easiest way for me to upgrade? Typically, what most people would do when they're upgrading or testing an upgrade is go to your module settings, and um, hopefully the screen is visible, Mala. It's readable.
Yes,
Okay,
yes, looks legible
awesome.
to me. Yeah.
Awesome, great, thank you. So when they come to the screen, they can go to the module setting and let us say go change your um, IDE to be, let's say, Oracle JDK 21. What you don't notice is the fine print that says, hey, IntelliJ Maven demo is imported from Maven. Any changes made will be lost right after you re-import. So if I were to apply this and go back and somehow re-import my Maven project, I can do that using a refresh. And I go back to my module settings, it will go back to Java 8. So the way we fix this is actually making a change to our Maven POM XML file. So you go ahead and make the change to 21 here, right? And this is, once you do that, you actually get this nifty little import button that IntelliJ provides, which allows you to load Maven changes automatically. I also have a shortcut. It's a Shift Command I, which is what I would use, and it automatically disappears as soon as I refresh or re-import my Maven project. So that is one nifty way in which IntelliJ allows me to upgrade. And if I now were to go and check my module settings, give me a second, it does go back to 21 and there is no issue with that. So if I were to change this to a different version, you will notice that IntelliJ will again warn me, right? So 21 is now set up and now I'm on Java 21. So it does make the change from, let us say, an upgrade being tedious to something much more simpler and controlled by your IDE. Now, other cool things that IntelliJ provides, which are very useful in a team environment. Let's also change this because I don't want the compilation to be, and I definitely want to enable preview mode. Okay, three things that I wanted to show you today are I've created some dependencies. These are not really useful in my Hello World app, but I wanted to share with you what works and what doesn't work with me. So once again, the refresh comes in. Let me just refresh this because I changed the compiler settings. And let's hover over this and see what Apache Maven or IntelliJ plus Apache Maven is providing you. It says that there is a transitive vulnerable dependency on this particular version of Spring Framework, Spring Web, when I use Spring Boot Starter Web. It can also be seen when you see the warnings up there. I'm just going to click this, and you will notice that it listed all warnings I have in my POM XML file. So in my POM, I have 6 warnings, and the first 3 warnings are for this particular dependency there, where the Spring Web, WebMVC, and SnakeYAML are all dangerous. So let's go try fixing this. Easiest fix, let's upgrade Spring Boot. So let's go to the latest Spring Boot version, 3.1.5. Awesome. So I moved it to 3.1.5. The highlight disappeared, but I still need to refresh, re-import, and I re-import my project. And guess what? It again failed. What is going on? Why is there another warning? So if I were to now go look, looks like Spring Boot hasn't caught up to SnakeYAML. They're still on version 1.3.3, and IntelliJ figured that out for you, right? So now if I were to add a dependency of SnakeYAML and org.yaml, and I pick the latest dependency, and I refresh, most of my vulnerabilities will disappear. So that's something IntelliJ is providing out of the box for you. It's very useful to know. Similarly, I know I'm using an older version of Netty on purpose. It is 4.1.54, and the latest is 8.6. I happen to know this because I use this quite a bit. So if I were to refresh, my Netty vulnerability disappears. Okay. But the third and most cool thing IntelliJ does is I didn't even have to do that. I could simply look at this JUnit problem and it says, hey, change from this to this. And if I were to just click this button where it currently is on 4.12, it'll magically move it to 4.13.1. So let's take a look. I'm going to do an option enter, and I'm going to select change this, and it took care of that for me automatically. So IntelliJ is not just smart enough to detect, it is also smart enough to help you overcome the vulnerability and provide a solution, right? So that's quite useful and nifty to know. Before I move to the last topic, are there any questions on what I shared so far?
So let me quickly ask you one question about. So there's another question by the same person, by Sagar, and I believe he's trying to ask: is there an option to share which JDK I could use in the POM itself? Like, of course, when I use IntelliJ IDEA, I could specify whether I want the Oracle's JDK or I want the JDK from Amazon. Is it a way to specify the same in the POM as well?
Yes. So not exactly in the POM, but there is something called a tool chain that you can set up. So Maven provides you what is
Okay.
called a toolchains.xml file. And toolchains.xml file allows you to name the JDKs, right? So you could, let us say, have
Okay.
a Java 21 from Oracle, a Java 21 from OpenJDK, a Java 17 from Azul or whatever, and you want to run your build with all of these. The way you do it is you create a toolchains.xml file and you specify these three versions, give it some names that you prefer, and in your profiles or in your Java code, you can just say, I want to use this version from the toolchain. So Maven toolchain plugin comes in handy, allows you to pick up the version of Java that you use. Should time permit, I already have some source code on GitHub which does toolchains XML, and I could share that. Or if you want to contact me after the session, happy to share with you some code that will get you a starting point on how to use toolchains. Hopefully that answers your question.
That was great. So there's another question by Vishal, and he wants to kind of revisit the nearest in depth for dependency resolution that you covered.
We'll get to
If
that in a minute. Okay, awesome.
okay.
That's a great question. So
Mhm.
thank you for that, Vishal. So we just made some changes here, right? So we went through, changed Spring Boot starter web from 2.7.12 to 3.1.5, and we added Snake YAML. And here is where our dependency nearest path resolution will start showing up when I go to a terminal window. So let's go to a terminal. I'm going to use real terminal, not IntelliJ, because I need to capture the output. So bear with me while I do that. So CD projects. And bear with me while the font is small. I will increase the font in a bit. Conference, and under conference, I'm going to. So let me just increase the font real quick. Hopefully this is visible. So I have my POM XML file that I just changed, right? You can see 11:44 my time is just now. So I just changed this. Okay. So if I were to run a Maven dependency :3, and I'm going to do a -d verbose. And I'm going to move this into a deps.txt file. Okay, and there's a reason I'm doing all this. Let's take a quick look at deps.txt. Okay. So this is my dependencies, and pardon the dark screen, but let's take a quick look at what happens here. So you'll notice that there are a lot of omitted for duplicate values that start showing up when you do this, right? That is something important and useful to know, but we'll cover that in a bit. But here is your dependency resolution nearest path. So where you had Snake YAML 1.3.1.33 from Spring Boot, your nearest path is to 2.2 that you set on your class path, on your actual path, and that is what gets precedence. So how does this work? It actually goes through and looks for everything that is potentially a duplicate, and then it builds a graph. And based upon the graph, it calculates which one came first, which one is nearest in depth. And here is an example of what I'm going to show you next. So going back to the IDE, give me a second. I go back to my IDE, and just to prove my point, I am going to go ahead and add another dependency up top. So don't do this, not recommended, but I'm going to show you because this will help me prove my point about nearest in depth and first in resolution. Second 1.30. So I have version 1.3 here. This has Spring Boot Starter Web has 1.33, and my Snake YAML declared below is 2.2. And I'm going to prove to you that 1.3 is the one that gets picked up. So if I were to go back, and let me just close the deps.txt so I don't overwrite it while it's open. And let me run the Maven dependency again. Okay, so let's open this. And if I were to open the deps.txt, obviously it is going to tell me that I have some very bad things going on. I should not be doing this. So you should fix this. Maven is intelligent enough to tell me that. But if you were to notice the tree, you will not notice a Snake YAML anywhere. And if you were to scroll all the way up, so what got picked up? Where is that showing up? Snake YAML. I save my changes. Let's see. Next 2.2, 1.3. I don't believe I saved my changes. Did I save them? So you know what? Forget the command prompt. I'm just going to show you an effective POM from here, which is the same thing. Where's my POM XML file? And Maven effective POM should pick up Snake YAML version. Oh, I'm sorry. Did I just put? Give me a second. My bad. I should not have done this. I should have put this elsewhere. But anyways, it is possible, and I don't want to spend too much time on this, but if you have this question, I can do this after the demo. I'll show you how it works, and you'll notice that it'll pick up the nearest in the first one. But my apologies, I'm running short on time, but should you want to catch up right after this call, I am happy to show you what I'm talking about. Anyways, the next thing I wanted to cover is when I were to, if I'm working in a team and I have a specific Maven command, usually what most people do is they put this command somewhere in some documentation site and say, run this command for this project. And everyone goes there, copy paste that command, puts it in the run configuration and runs it. There are better ways to handle this. And a better way to handle this is when you create your run configuration, you go edit your configurations, create a configuration. Let's assume we're creating something that is complex. So my complex command could be clean install -d special condition equals true, right? Something like that. I don't even know what it is, but this is your command. So what you can say is my team command, or give it some other name, and store it as a project file. So you can actually save your run configurations and check them into your Git repository, and they are available for everyone to use. And once you set it in a specific location, if not your IDEA, I actually put it in a specific folder called the IDE, and I save it. Others I've seen put them under source IDE. So there are different ways in which you can put it, but wherever you put this, this is now available for others to use. So a local test run is available. If you open this, this is actually a run configuration, and IntelliJ is smart enough to identify that, and it says, hey, open the run configuration. So it allows you to go back to it and save it as a project file, right? And then you can reuse it at a later point in time. So other team members can simply check out the code base. With the code base, they get the run configuration, and they don't have to refer to some documentation site to pick up the commands that they need to run on the project. The last thing I wanted to cover before we run out of time is when I talked about how plugins work in IntelliJ. And let's show you a real quick example of how to set up a plugin and do the same with the run configuration and save it actually, right? So I'm going to exit out of this run, and let us go back to our run configurations. And before I do that, just a very quick walkthrough of a plugin, right? I created a small plugin. In fact, I created this today. So not even like yesterday, this was done like a few minutes ago, where I created a plugin called Hello Mojo. It's a very complex plugin. It actually prints Hello Dr. Chandra. It doesn't do much. It just prints Hello Dr. Chandra, right? And this is how a plugin is set up. You create a Mojo. A Mojo is basically what a goal is. A plugin has a goal. So this is my plugin project called Hello, and it's got a Hello Mojo, and the name of the Mojo is Hello, and the default phase I have associated it with nothing. So it does not attach to any known lifecycle phase. It just exists, right? And if you notice, I created this like a few hours ago. So I built this, and let's either embarrass myself or actually prove that this works by invoking it in one of our commands. So if I were to go to a terminal, and let's assume I clear my terminal, and let's run this command. Let me paste this real quick. Let me run this command. So why am I running this specific command? Maven clean, and pardon my fonts, but Maven clean, which is a clean lifecycle, clean goal. Then I call none CVG, which is the group ID, hello being the artifact ID, version being 1.0.0, and the goal name being hello. And where did I get all this information from? So if I were to go back to my plugin and look at the POM XML file of my plugin, my group ID is none.cvg, my artifact ID is hello, my version is 1.0.0, and I am calling the hello goal. And that is what I'm doing in my command prompt. And if I were to hit enter, it runs through the code, and it does everything. And you will notice somewhere in here, it prints hello, Dr. Chandra, right? So that's how Maven is basically working either with the lifecycle phases or custom plugins that you develop and invoke on the command prompt. So you can do either. What Maven does when you call, let us say, give me a second. What Maven does, let's say, when you call the clean, is it actually calls the Maven clean plugin version 2.5 and calls the clean goal on it, which means it has called a pre-clean and a clean for you, right? And that is how Maven works. In the end, lifecycle, the phases attach themselves to plugin goals and are executed. So when you call process resources, Maven resources plugin gets picked up, and the version 2.6 of that plugin gets picked up, and the resources goal is invoked, right? The only difference is that when you call clean, I did not have to specify a group ID and artifact ID for the plugin. It was picked up by default because these are standardized plugins available from Maven. When you create your own plugins, there are a few ways in which you can handle it. Either you provide the complete group ID, the group ID is this, none.cvg, the artifact ID, hello, the version number for that particular plugin, and the goal you want is all invocable. Or you can set up different ways in which you can make default the none.cvg group. And therefore, if you were to just say hello 1.0.0 or even just hello colon hello, it would work. Is it possible? Yes, but it requires some amount of setup. So just letting you know that's a possibility. So with that, I think I'm going to call it a wrap. But for the question about the person resolution, if you still have that question, we can talk right after this. Mala, over to you.
So, first of all, thank you so much, Chandra. And before I uh, start with our question and answer session, here's a QR code which everyone can see on the screen right now. Also, a link to a very quick survey on this session that we are hosting right now. If you could submit your feedback right now, it will help us to plan our future sessions. Very quick survey, just would take, I think, 1 or 2 minutes of your time. And I would also paste a link to the survey on in the chat. And when we do that, so let me ask the first question to you, Chandra. I had my mouse on that question and now it's gone. No, I have it now. Okay. So Adam mentioned that he was working with Maven 3.9x and he thinks that Maven switched to Java HTTP client and they have some SSL problems. Is there any option to skip SSL verify now? Would you like to answer that? Chandra, we can't hear you now. I think you are muted.
Somehow I got muted. My
Okay.
apologies. I may have pressed a Command D and it probably muted me. My apologies to everyone. Yes, the answer is can you do that? Yes, but the bigger question is why are you doing that? Unless you have a repository that is still HTTP authenticated, my suggestion is to avoid that. There are quite a few Stack Overflow answers that allow you to do it, but please avoid doing that. It's a risky move.
Okay, so there's another question from EEM. How to resolve vulnerable dependencies if there is no new version, and should we exclude them in Maven?
That's a tough question to answer. I mean, it's a tough question in general because you absolutely need this dependency, so you cannot exclude it. Should you use it? Well, if there is no other choice, what do you do? Provide some sort of mitigating factors around its vulnerability is one thing you can do, but also cajole the open source developer who's working on that or contribute to it are better ways in which you can solve it. But if it is a vulnerable dependency and you don't exactly need it, and there's a Maven, one of the things we could not cover today in the sense of time is basically that Maven provides dependencies at different scopes. So you have a compile time scope, which only works to build your code. There's a runtime scope, which is being used by Maven or your application at runtime, etc. Scopes could be different. So if you have an optional scope or a compile time scope, you're better off. But if it's something in the runtime scope, um, you want to do some mitigating factors around the vulnerability is the only way out. If it's not required, avoid using it absolutely, exclude it.
Absolutely. And if possible, look for an alternate dependency which could
Yeah,
meet the target.
agreed.
So there's another question by Sebastian. So I think it's related to one of the code samples that you showed. Is it safe to just upgrade to a new version like you did with Snake YAML? What about backward compatibility issues?
Great question, Sebastian. And the answer is no, it is never safe to just upgrade without looking at it. I happen to know the SnakeYAML 2.2 is backward compatible, so I was able to do that quickly. But with every dependency, right, you have to identify what impacts it has on your code. Typical analysis, as if you were putting in a new dependency, is required and is a must for clean code hygiene. So please don't just blindly upgrade. Do review the release notes and any gotchas that the developer posts about a newer version of the code base.
So there were a lot of questions which were multiple questions, and there was one answer by Nikita for all those questions. That was the dependency analyzer in IntelliJ IDEA. So if
Oh,
you
I
want
should have
to,
mentioned that. Yeah,
yeah, I know because you covered so much, and I'm sure if we even have multiple sessions, it would be less to cover all the complexities and all the features that Apache Maven offers. So yes, we would not be able to cover everything in one session.
that's fair.
So yeah. So there's another question. Yeah, I'm not sure how much time that would take. If it's a short one, you could take that. Otherwise, we can skip that one. So Giovanni is asking, what is the difference between a phase and a goal?
Okay. A phase is something that is associated with your life cycle, right? So, in a sense, what a phase is Maven's way of understanding what needs to be executed. So, Maven just understands phases, and plugin goals associate to those phases, and the plugin goals get executed. So, um, the phases by themselves are meaningless, right? You can have 1,000 phases which do nothing. If there is a plugin associated with that phase somehow, or made to associate with that phase because you put it in your POM XML file as when you add a plugin, you can add a configuration for the plugin and say, hey, I want this plugin to run when this phase gets invoked. And you can do that manually, or Maven does some defaults for you. But either of those is how a plugin's goal gets executed. And that is Maven's way of execution. There is a phase by itself. Let's assume I now call a Maven clean and I don't have a Maven clean plugin. It's not going to do anything. It does not run, right? Or if I call Maven process resources and I have no resources, it does not run any plugin for me. If there is a plugin and it is associated with that phase, is what gets executed by Maven, right? So that is the key way to look at the difference between the two. I don't know if that answers your question.
Okay, I think that answers the question. So if there are any follow-up questions, we'll look at that. And this is the last one that I'll take. So this is from Akshay. He's saying hi from Eclipse team. We also have Christian from JUnit team and a lot of other known folks. So that is great. So he says thank you. And there's another question. Is there a way for us to access your presentations by Mycola?
Yes.
So Chandra already shared the link to the presentations early in the session, and we'll also add those links to the description of the video so you can check them out right after we close the stream. And yeah, so I think we are done with the question. Thanks to Nikita, who was answering a lot of questions.
Thank you, Nikita.
So and of course, thanks to you, Chandra, that was a great session, great explanation of the concepts. Because yes, we see the implementation and doing code samples in IDEA, but covering the concepts, all the theory behind it, that was really helpful. We had multiple comments on how useful that it is, and Akshay already saying make part two for the session. So
Thank you
yes,
so much.
thanks. Yeah. And before we close the stream, if you would like to share any closing remarks, Chandra.
No, thank you for allowing me to present here. I had fun presenting. Hopefully, there was something gained out of this. And should you have further questions, my contact information is up there. Please feel free to reach me. And I look forward to more interactions. Any feedback about the session is also good for me. Thank you.
Yes, thank you so much. And everyone who's watching, please try to fill up the form, the link to which we already shared in the chat, and we showed on the screen as well. The feedback would be shared directly with Chandra. So any input that you provide us would be shared with Chandra. So thanks everyone who's watching. Big thanks to everyone. Of course, to Chandra for presenting today's session, Sergey from the video team, Anna Zlata from the marketing team, Daniel from the graphics team, and everyone else involved. A lot of people work for this session. And also everyone who's watching right now, stay tuned for our next IntelliJ IDEA live stream, which will host on Thursday, 9th November by Marco Bello on JPA Bari. So until next time, thank you very much.